Hello everyone, welcome to RN tutorials on engineering mechanics. So now we are going to discuss about theorem of parallel axis for moment of inertia. So in this session I would like to explain what do you mean by theorem of parallel axis for moment of inertia and how can we derive the equation for the theorem of parallel axis for moment of inertia. Okay, here the statement I would like to give first. The statement is given like this. It states that a moment of inertia of a plane area about any axis parallel to another axis passing through center of gravity of plane and at a distance of h is equal to sum of moment of inertia about cg and the product of area and the square of distance between the two axes. Okay, this is the lengthy statement, but I can make it simple by using certain diagram and using formula. So finally by this statement we can write, first I would like to show you the figure. So this is the figure. Assume plane area with a particular reference line AB and from CG line which is at a distance of h, and the formula finally we'll be getting IAB is equal to IG plus AH square. So there is another statement here. So once again go through the statement. So it states that moment of inertia of a plane area about any axis parallel to another axis. So this is the moment of inertia about a particular axis which is parallel to another axis and that is passing through the center of gravity of the plane and at a distance of h is equal to sum of moment of inertia about CG, sum of moment of inertia about CG and the product of area and the square of distance between the two axes, that is AH square. Okay, so from this statement we can write the equation like this. That is the moment of inertia about any axis which is parallel to the axis passing through the center of gravity is equal to sum of the moment of inertia of that plane about the center of gravity and the product of area and the square of the distance between the two parallel axes. Okay, that is the statement of the theorem of parallel axis. So next we go for derivation for that. Okay, for the same figure try to assume an elemental strip at a distance of y from the center of gravity line. So from the center of gravity line assume an elemental strip at a distance of y. Okay, and for this assume the area as dA. Okay, this elemental strip small area as dA, and next we have to write what is the moment of inertia of the strip about CG. So the moment of inertia about the CG we can write it as general formula we know, perpendicular distance square into area. So that can be written as for this elemental strip only. So for this elemental strip the moment of inertia can be written as perpendicular distance, that is y square into area of the strip dA. Okay, so when we want to write the moment of inertia of the whole section about CG, we need to apply the integral with a particular ranges, limiting values. So the moment of inertia of whole section about CG is equal to, that is IG represented by IG is equal to integration y square dA. Okay, this integration is applied according to the limiting values for covering the entire section. Okay, and next remember this formula, and next we go for moment of inertia of the strip about AB line. So this AB is parallel to the line which is passing through CG. So with respect to this AB line, what is the moment of inertia for this strip? We need to write the same formula, perpendicular distance whole square into area of this strip. So the perpendicular distance is h plus y whole square into area is dA. So that we write here h plus y whole square into dA. That is the moment of inertia of only this small elemental strip with reference to the AB line. Okay, so again how can we write the moment of inertia of the whole section about AB? We need to apply the integration h plus y whole square into dA. So try to elaborate this h plus y whole square as a plus b whole square. So integration of h square plus y square plus 2hy into dA. So now take the integration and the dA inside, then we can write it as integral h square dA plus integration y square dA plus integration 2hy dA. Okay, so when you keenly observe here, this h square dA, h is constant. Okay, so integration dA, that means sum of the areas of small elemental strips which will be covering whole area, so that will be equal to area of the whole section. We can write it as capital A, h square A a into h square we can write it as, that is integration dA will be equal to a only. So here integration is applied with reference to the limits which will be covering the whole section area. Okay, so that can be written as capital A, which is the area of the whole section, and plus y square dA. So this y square dA is the moment of inertia of this elemental strip with respect to the line which is passing through the center of gravity. So that can be written as Ig plus, and again here this 2hy dA, 2h is constant, again y dA. So this integration y dA represents the moment of the area, uh, area moment of area. So that moment of area, again integration with limits means some of the moments of area we can consider. So that can be finally written as ay bar. So why it can be written as ay bar means, already we know the center of gravity formula, center of gravity, finding the center of gravity, x component, y component. So this is similar to that y component only. So how it will be means, here y bar is equal to, we know that a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3 up to how many elemental strips we are going to consider. So similarly integration yda means, okay, it is the moment of area. So this we can consider a1 and y1. So integration, in place of integration, again we can write the sigma also, which will be consisting of some of the moment of areas like a1 y1 a2 y2 and a3 y3, like this. So this integration yda can be written as a1 plus a2 plus a3 up to how many elemental strip areas we are considering into y bar. So that some of the areas we can consider as a whole area of the section. So we can write it as finally a into y bar. So here y bar is automatically 0. Why? Because at the center of the circle only the CG will be taking place. So automatically y bar becomes 0. So y bar is 0. So when you substitute y bar is 0, finally we will be getting IAB. That is the moment of inertia of this plane section about any line AB which is parallel to the line passing through the CG is equal to sum of IG, moment of inertia about the center of gravity, plus ah square, product of area and the distance between, and the square of distance between the two parallel lines. Okay, that is the theorem of parallel lines. So this is the derivation. I hope you understand. According to the statement, we have derived the equation, that is IAB is equal to IG plus AH square. I hope you understand. If you still have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video. Thank you all.